Okay, so we are going to continue this example. Again, this is Unit 2, Lecture 2, Part 2. Okay, we're talking about angled projectiles. So we've just found our initial velocities in both directions, the x and the y, by using trig functions to break down the hypotenuse of the initial velocity. So we filled in our charts as much as we can at this point, and this is where these problems get a little bit tricky. So the first question is, how long is the mortar in the air? So in order to figure that out, we're kind of lost here. We don't have enough information on this side, and we don't have enough information on this side quite yet to solve for anything. So what we're going to have to do is we're going to have to think about this projectile as it flies across the air here. And there's an important spot right at the top up here. And the key is that as the projectile comes up, when it hits this very, very top point, it will only be moving in the x direction at that point. And so what we can say is that the v final in the y direction is 0 at this point. Okay, so we're just talking about this maximum point. So what we'll do is we'll temporarily put that in as the final velocity in the y direction. We'll use those facts, and we'll just have to keep in mind that anything we find using that number will actually give us, the time just to this point, the displacement just to this point. Okay, so if we want to know how long the mortar's in the air, we're going to need to find the time. We have to use this column because it's where we have the most information. And we want anything that doesn't have the displacement in it because that's the one variable we don't have and we're not looking for. So the equation we want to use is VF squared equals, not that one, just VF, not squared, equals V naught plus AT. VF we're going to say is 0, right, for now. VI, or V naught, is 139.3, A is negative 9.8, and T. And we're solving for T here. Okay, so let's plug that in. So 139.3. So I got 14.2 seconds. Now here's what's really important. Since we used this 0 as the final velocity at this point, it's only giving us the time to that point. So we're going to go ahead and put a 1/2 here because it's only giving us the time from the start to the very, very top. And then it's going to take the exact same amount of time to get back down to the bottom. These projectiles are very symmetrical, so the time it takes to get to the middle will be the same the time it takes to get from the top back down to the bottom. So this is t 1/2. So if we want the total t, we just have to multiply that by 2, and we get 28.4. Okay, so that's the first part. Now the second part says how far away, so I'll just label this A. Let's put B over here. How far away does the mortar land, and what is the maximum height the mortar reaches? So in order to figure out how far away the mortar lands, it lands after the full time has passed. So we can take this 28.4 and we can put it in to that x direction. Since we're looking for how far away does it land, we're looking for the d in the x direction. So we're in this column now. Remember, you cannot mix columns. Don't use stuff from the y column and stuff in the x column in the same equation. Okay, so if we're on part B, we're using the x column, which means we only have one equation. So we say 97.5 equals d over 28.4. And if you actually multiply that, you get 2,772 meters. Okay, and that's how far away. Be careful that you don't use the half time, because that will just get you the distance to the middle. Okay, and then part C says what is the maximum height. So if we're thinking about the maximum height, that's the d in the y direction, the up and down direction, and it happens at the halfway point. So the key here is that we use the halfway time if we're going to use the time to find that displacement. So we're in the y direction, okay, and we'll go ahead and we can use that, or we can use this 0. It doesn't really matter. The easiest equation to find d, I think, is this one. And so if we plug into that, we get initial velocity is 139.3 times time. Remember, this is the half time. Plus 1/2, negative 9.8. And then if you go ahead and plug that in, you get D equals 990 meters. Okay, that is pretty much as hard as it gets for these problems. So that's a really good example to go back and look at before a test. Okay, and then let's go ahead and look at example 2 here. It says a football player kicks a ball that is 36 meters away from the base of the goal. So we know that this measurement is 36 meters. If the crossbar of the goal is 3.05 meters high, will a ball kicked with a speed of 20 meters per second at an angle of 53 When they give you the velocity like that, it's the initial velocity on the hypotenuse, unless they specify that it's in the horizontal or the vertical direction. Okay, so you should automatically draw those arrows to break it up. So will it clear the goal is the question. Okay. Make our little XY chart, right? And this is the question, whether or not that's going to clear. All right, so your first step is going to be to find the Vx, or the V initial in the X, and the V initial in the Y. We know this is negative 9.8. We know the dx is 36. We can't plug in 3.05 as the dy because that's just the height of the crossbar, and we're trying to figure out what the dy would be at that point. So we really can't plug in that. We need to find the actual and then compare it to that and see how it comes out. Okay. We can use our cosine and sine to find our Vx and our Vy. So Vx is going to be cosine 53 times 20. And Vy is going to be 20 sine 53. This is actually a better way to write it because that way you don't actually accidentally put the 20 in the cosine. So make sure you do 20 cosine 53. And if you go ahead and do that, you get 12, so Vx is 12.04. You could just put 12.0. And Vy is 15.9, or about 16. Okay. Next step would be, we're trying to figure out what's going on here. What's the dy here? That's going to tell us whether or not we have crossed this bar. So we're really looking for this, but we don't have enough information here, and the only thing that we can do is find the time here and then put it over here. So we want to find how long does it take the ball to get to that point, right? 36 meters away. So we can use these numbers. And then if we do that, we see that time equals 3 seconds to get there. So then we can plug that in here to this part. And we can figure out how high is the ball after 3 seconds. So in order to do that, we don't want Vf in the equation. So we're going to use d equals v naught t plus 1/2 at squared. So d is what we're looking for. V naught is 16, t is 3. A is negative 9.8. Again, t is 3. Don't forget to square it. And if we plug that in, we get d equals 3.9 meters. And so we can say, yes, it does clear. And we know because 3.9 is higher than 3.05. Okay. Don't think there are any other examples for this one, so I think we're set. All right, just go ahead and review that a little bit, and we will practice some of these in class. These are a little bit harder than last unit, so This is where you have to start putting the time in. All right, see you in class.